안녕하세요. 저는 기후변화와에 의한 산불과 화작농업으로 인한 토양 수분 순환 시스템의 파괴 확인 및 황토 이온의 수분 흡착력을 이용한 해결 방안의 연구 주제 보름 본선에 참가한 고린입니다. My motivation to study this area in particular stemmed from experience from my sister who currently resides in California, a state with phenomenal amount of forest fires. This led me to discover the ones happening in Australia. However, the main reason for this sudden exponential increase in forest fires is due to the global phenomenon of climate change. Moreover, I found that carbon dioxide generated during a large-scale forest fire further contributes to promoting global warming. Research methods and results. I first conducted 2 studies to confirm what changes would occur to soil when a forest fire occurred. As a result of collecting soil from the area where the forest fire occurred and comparing it with general soil, I could see that the soil in the area where the forest fire occurred was more dry due to lack of moisture. In fact, the first study showed that the soils in forest fire do not absorb water and it evaporates rapidly. And so it was confirmed from experiment 1 and 2 that the soil where forest fires occurred did not normally absorb water from the atmosphere. Next, for my third experiment, I wanted to imitate the scenario of a forest fire. After putting 10 grams of general organic soil in a stainless steel container, as well as dried leaf plants, I lit it on fire. Although the process increased the fertilization content of the organic soil, its ability to absorb water and the moisture in the unabsorbed soil rapidly increased. This was a study that proved that man-made wildfire conditions also cause the same problems as wildfire soils. In order to solve this problem, I determined that returning a polarized charge to soil was the answer. Since water is polar, if you increase the polarity within soil, water intake in the soil will increase. I chose yellow clay as my solution. Yellow clay is an eco-friendly material rich in various minerals and ions. The cations present in yellow clay were separated and purified in experiment 5. After separating the charged ions, I administered the liquid solution into the soil in order to make sure that the yellow clay was not inhibiting plant growth. I conducted tests, as you can see in the graph, to show that the levels of anaerobic and aerobic bacteria were equal. Cations and anions that were separated from the yellow clay that were then administered to soil can be seen on having no effect on the growth of soil bacteria. Both experiment 7 and 8 was used to determine the ability of water movement between the charged particles as well as the ability to evaporate. When cations and anions extracted from the yellow clay were administered, the water cycle of the soil was restored normally, and based on this, it was confirmed that the amount of methane produced was reduced by greatly reducing the methanogenic bacteria. In experiment 9 and 10, as aerobic and anaerobic soil bacteria recover, methanogenic bacteria decreases, which we can conclude as the soil recovering. In experiment 11, I planted the same type of plant into soil that was destroyed by forest fires. However, one of the plants I administered my yellow clay solution, it was confirmed that the plant was able to grow normally in the soil with ion solution. This phenomenon is probably because the cations and anions of the yellow clay increase the water retention capacity in the soil, decompose organic matter in the soil ecosystem where the water is absorbed, and perform the function of the soil. Through the research process, it was confirmed that the soil has been exposed to forest fires or man-made fires. The evaporation is accelerated and plant growth is inhibited in that particular soil. It is also found that the number and type of soil bacteria that were able to live in it were significantly reduced. As a solution, I was able to confirm through several preliminary investigations that the water retention capacity of soil can be increased by administering cations and anions that were separated from yellow clay. When cations and anions extracted from yellow clay are administered, the water circulation of the soil is restored normally, and based on this, the methanogenic bacteria are greatly reduced. The number of aerobic and anaerobic bacteria in the soil is restored to normal, and the overall soil function is restored. The result of this research is that cations and anions of yellow clay can be used to restore the water retention capacity of soil, which can be key to suppressing the proliferation of methanogenic bacteria in the future, and research that can contribute to the restoration of vegetation in soil suffering from forest fires. This is the end of my presentation. Thank you for listening.